Our lesson on 6-7 is titled Using the Fundamental Theorem of Algebra, but we're actually going to kind of cheat and use our calculator more than the fundamental theorem. We're going to continue our discussion about using synthetic division to kind of break down a polynomial into a smaller component. So, first thing we need to discuss are the steps that we're going to use today. Now, like I said, we're going to kind of cheat and use our technology to get us going. So our first step is we're going to use our graphing calculator to determine an easy x-intercept. Now, easy meaning it's going to be a pretty number, like -2 or 4. I don't want any decimals on this. I'm not going to give you any problems that you won't be able to find an easy x-intercept, and if the case ever arose where you didn't have a calculator to do this, that's where we would use what's called the fundamental theorem of algebra, but we're not going to go there in Algebra 2. You might see that a little more in college algebra. Now we're going to take that easy to spot x-intercept and we're going to divide it using synthetic division into the polynomial, and we're going to keep doing that until we get down to a quadratic. Now once we've broken it down to a quadratic, we're going to use one of our techniques, probably factoring, possibly quadratic formula, to find the rest of the zeros or the solutions. Now I realize that you could possibly use your calculator to find all the answers, but that's not our goal here today. We're only using the calculator to start the problem. I need you to show work on all of these problems, so I ensure that you're not cheating by using the calculator the whole time. And there's a couple of notes at the bottom. It says you will find the same number of solutions as the degree. So if it's a degree of 4, you're going to be finding 4 solutions. And sometimes we'll run into something called multiplicity. If you notice that the graph bounces off the x-axis, doesn't actually cross through it, but bounces off at a point, that means that that solution shows up more than once, probably twice if it's bouncing off. When you go to college algebra, you'll see cases where it has even versus odd multiplicity, or more complicated multiplicity than what we're going to see. But in our class in Algebra 2, we're just going to concentrate on multiplicity of 2. So let's see how this works. First, we need to take our function and grab our calculator and go ahead and type it into y equals and then look at the graph. So, once I can pull that up, clear. So go to y equals and type in x to the 3rd power minus 4x squared plus 3x. And then when you hit graph, you should notice that there's a couple zeros here, and I don't know which one you saw first, but the first one that caught my eye will be that one right there, and I see that he's crossing at the x-intercept of 0. So what I'm going to have you do, and you don't have to do it the same way I am, but these are notes, so you probably want to follow along with me. I want you to go back to your paper, and what we're going to do is we're going to write a little note that we are going to start with our x-intercept at 0. So what that means for us is we're going to set up synthetic division, where that easy to spot x-intercept goes in the box, and then our coefficients fill out the rest. So our coefficients to our poly are 1, -4, 3, and then did you notice there's no constant term here? So I have to put a 0 as a placeholder for that missing constant term. Now synthetic division, remember we start by bringing down the 1, and then it's a series of multiply add. So 1 times 0 is 0, -4 plus 0 is -4, -4 times 0 is 0, 3 plus 0 is 3, 3 times 0 is 0, and then that leaves us with no remainder. Now once we have it broken down to a quadratic, which I think we're there, we're almost done. I'm going to rewrite this with the coefficients where they need to be. So remember, we took an x to the 3rd and we took it down 1 level, so it's now a quadratic. So it's an x squared minus 4x plus 3. And my instructions here said find all of the zeros. So we need to somehow find our zeros or our solutions to that quadratic. Now most of you will select the factoring method, and I think that's the way I'm going to go here. So if I went ahead and set these, or tried to factor this, I'd get an x minus 3 and an x minus 1 equals 0. So now I'm ready to give my solutions. My solutions, remember the first one we found was x equals 0. And now if I set my two factors equal to 0, I would get x equals 3. And I would also get x equals 1. So these are my answers. I realize you could have just saw that on your calculator. However, we're practicing the skill that we're going to have to use on calculator problems that we can't use it for the whole problem. You need to show me this work on your homework, your quiz, and your test. I will not give you credit without you showing that work. Okay, moving on. Let's try the next example. So you're going to go ahead to y equals and type in that function. Oops. So we've got x to the third minus x squared plus 49x, and then minus 49. Oops, that was supposed to be a 9. 9. Now, I can only see one of the x-intercepts now, so what I'm going to do is I'm going to make a little note here. This x-intercept is crossing at 1, so my note says that I'm going to start with my x-intercept of 1. And we're going to set up synthetic division. Let's get a bigger screen here, where I put that x-intercept in the box, and then I write my coefficients of the original poly. So 1, negative 1, 49, and then a negative 49. Okay, remember we bring down the first coefficient, and then it's a bunch of multiply, add, multiply, add, multiply, add. So 1 times 1 is 1, add those together, you get 0. 0 times 1 is 1, add those together, and you get a 50. I feel like I did something very wrong. Back up a minute. That's because 0 times 1 is 0, not 1, Mrs. Abruzzo. Try again. Okay, 49 plus 0 is 49. 49 times 1 is 49. There's my 0 remainder. So right away, I can write this as is quadratic with these coefficients. So we have x squared, there's no x to the first term, and then a plus 49. Well, remember, I'm supposed to use some sort of technique of factoring or some sort of quadratic technique to find my two answers. Well, if you think about x squared plus 49, you could technically factor him using the sum of squares pattern that we learned, or you could just solve this via a square root. So if I subtract 49 from both sides, and then I tried to square root the negative 49, you should remember what happens here. The square root of a negative 49 is a plus and minus 7. So my first answer was x equals 1, and then I ended up 7i, excuse me. My second answer that came with positive 7i, and then remember it also had a negative 7i. So I didn't mention this on the first problem, but notice we have 1, 2, 3 solutions, and the degree of our original polynomial was a 3, and that's exactly how the last problem worked out as well. That's always going to happen. It doesn't mean you have 3 real solutions, it just means you have 3 solutions. And in our case, we had 1 real solution and 2 complex or 2 imaginary solutions. Okay, our next problem, we're going to have to go to our calculator and type that baby in so we can get an easy starting point. So, if I clear that out, we now have x to the 4th plus 5, x to the 3rd plus 5x squared minus 5x minus 6. Oops, that was supposed to be a 6. Alright, now when I hit graph, I see a whole bunch of solutions I'm going to be finding. So I'm just going to pick the first one that I noticed, and the first one I happened to notice was x equals 1. Which was this guy, or, oops, try again, this guy right here. So when I do synthetic division, write kind of small on this one because we're going to have to do synthetic division twice, and you'll see why in a second. I'm going to put the 1 in the box, and then I've got coefficients of 1, 5, oops, 5, it's not a 5, it's getting late, 1, 5, 5, negative 5, and negative 6. So when I go ahead to do synthetic division, 1 times 1 is 1. 5 plus 1 is 6. 6 times 1 is 6. Add those together, you get an 11. 11 times 1 is 11. Add those together, you get a 6. 6 times 1 is 6, and then there's no remainder. The reason we can't just stop here is we have too many terms. This is not a quadratic. This is only a cubic, an x to the third. We're going to have to do synthetic division all over again. So I'm going to go back to my calculator real quick. Whoops, maybe. Turn them on. And I need to choose another x-intercept that I'm going to work with. And just kind of, it's the first one I saw. I'm going to go to the next one in line, which is the -1. I can see that he crosses at -1. So let's go back to our synthetic division. And let's go ahead and divide our remainder here, or what's remaining, I should say, by a -1. So 1 times -1 is a -1. 6 plus -1 is a 5. Then we get a -5, 6, -6, and no remainder. So now we're left with a quadratic, just something with 3 coefficients here. So this is really an x squared plus 5x plus 6. And remember, our task here was to find all of the solutions. So let's go ahead and try to factor that. It factors really easy. Multiplies to 6, adds up to 5. I'm thinking plus 3 and a plus 2. So if you think about how many solutions we're going to have in this problem, this was a 4th degree polynomial. We're going to have 4 solutions. So our solutions are, remember the first one was x equals 1, and then we had x equals -1, and then the last two we found were x equals -3 and x equals -2. It doesn't matter what order you list them in as long as you list them all out. And again, I know you could have got all those answers off of your calculator, but we're practicing the method. They're not always things that you can do on your calculator, so yes, you have to show me all that work. Okay, moving along to our next problem. Got to go to our calculator and type it in. So x to the 4th plus 6x to the 3rd plus 14x squared plus 54x and then plus 45. Alrighty. Whew. Well, the good news is I can see 2 x-intercepts really easily. The bad news is that's all I can see, so if I was trying to cheat, I'd be kind of out of luck here. So good thing I know how to do the synthetic division breakdown. So the 2 x-intercepts that I see we're going to have to use are at -1. You see this guy is -1, and then this guy is a -5. So you might want to make a little note to yourself so we don't leave the screen too often. We're going to have to do this at -1 and at -5. And it technically doesn't matter where you start. I'm just going to randomly choose to start at, I don't know, -5 for fun this time. So let's put the -5 down. Our coefficients are 1, 6, 14, 54, and 45. And let's break this down. So we're going to bring down the 1 and then multiply, add a whole bunch of times. So let's see. So -5 adds up to a 1. 1 times -5 is -5. That adds up to a 9. 9 times -5 is a -45. That adds up to a 9. 9 times -5 is a -45 again, which gives me a remainder of 0. Now as you can tell, we're not broken down to a quadratic yet. We need to break it down one more time, and that's why I kind of jotted down the other x-intercept that I'm going to have to use here. So I'm going to have to do synthetic division one more time on the remaining polynomial with the -1. So you bring down the 1. 1 times -1 is -1. Add them together, you get a 0. 0 times -1 is 0. Add them together, you get a 9. 9 times -1 is -9, and you get a remainder of 0. So if I think about what's happening here, remember this is a remainder, so ignore that completely. We have an x squared, no x's, and then a plus 9. And we're supposed to find our solutions. Well, similar to the last problem, we're going to end up with, a couple problems ago actually, we're going to end up with i's. So you can either factor it, or you could subtract the 9, and then square root both sides. And remember, when you square a negative, you get positive and negative 3i in this case. So my solutions, and I got to list all of them out, are x equals -5, x equals -1, x equals 3i, and x equals -3i. And remember, this was a 4th degree polynomial, and I just gave you 4 answers, so I can feel confident that we're good to go. Now, on the next problems, we're going to work backwards. I'm going to tell you the zeros of your polynomial, and then I need you to go back and write my polynomial in standard form. Now, let's think about what this means. We have a 0 at 2, at 1, and at 4. So if I think backwards, that means that at some point in my life, my polynomial, which I'm going to call p of x, if it has a 0 at 2, that means he must have a factor of x minus 2. And if he has a 0 at 1, or solution at 1, he has a factor of x minus 1. And if he has a solution at 4, he's got a factor of x minus 4. Well, this polynomial function is not quite in standard form yet. We're going to use our techniques from 6.3. So remember, I always have you multiply the back two binomials together. And you get x minus 2. And then multiplying that binomial times that binomial, you get x squared minus 5x plus 4. And now we're going to have to do some more distribution. X times everybody gives you x to the third minus 5x squared plus 4x. And then -2 times everybody gives us -2x squared plus 10x minus 8. And after I combine my like terms, my polynomial is x to the third minus 7x squared plus 14x and then minus 8. And that is your final answer. So a little bit of work because you got to FOIL it out, but it's actually really easy mathematically as long as you know how to FOIL and distribute. Okay, the next problem. Since I have a 0 at -2, that means my original factor was x plus 2. And then a 0 at -4 means my original factor was x plus 4. And then if my solution is -7, my original factor was x plus 7. So again, I need you to FOIL this out, or distribute this out. Let's multiply the back two together. And you're going to get, x plus 2 hasn't changed, but we still have x squared plus 11x plus 28. And then if I go ahead and FOIL, or distribute, I distribute the x to everybody, and I get x to the third plus 11x squared plus 28x, and then I do the same thing with the +2, so I get a 2x squared plus 22x plus 56, and then when I combine my like terms, my final polynomial is x to the third plus 13x squared, let's see, plus 50x plus 56. There we go. So again, I don't think it's that bad. Now, here, they introduce the fact that you have an imaginary solution. And the thing about imaginary or complex solutions is they always come together in complex conjugate pairs. You'll notice on the problems where we ended up with imaginary solutions, the first one we had a positive and negative, I think it was 7i. And then in the next example that we had imaginaries, it was a positive and -3i. Well, that's how this works too. So when I think about my polynomial for number 7, since he has one of the zeros at 8, his factor was originally an x minus 8. And then one of his other solutions is an I, which means his original factor was an x minus I. Now because he's got to have a complex conjugate pair, conjugate, remember from 5.4, meant that he just had same binomial, just a different sign in the middle. So instead of x minus I, he's going to be x plus I. So what I'd like you to do, just like before, FOIL the back two together. So we've got, still have an x minus 8. X times x would be x squared. Notice on the conjugates, the outer and the inner are going to cancel out. and you're going to have negative I times I, which is a negative I squared. Well, remember, I squared is really a negative 1. So instead of saying minus a negative 1, I'm going to change that to a plus 1. And now we're ready to FOIL one more time. X times x squared is x to the third. Outer, inner, let's see, those aren't like terms, so we end up with a negative 8x squared and then a plus x. And then negative 8 times 1 is a minus 8. So that, believe it or not, is your final answer. So the trick there on number 7 was they only gave you one of the complex solutions. You had to know that his buddy, his conjugate pair, was the other one. Alright, then, same idea here. We've got one of our solutions is negative 5, so the original factor was x plus 5. Now one of his solutions is also a negative 2i, so his factor was an x minus 2i. Well, his complex conjugate buddy would be, instead of x minus 2i, would be x plus 2i. So again, we're going to go ahead and FOIL the back two together. And we get x plus 5. And then remember, conjugates multiplied together are really quite nice. X times x is x squared. I know the outer and the inner are going to cancel, so I'm not going to bother writing them. But we have negative 2i times a positive 2i, which gives us a negative 4i squared. Well, negative 4 times an I squared is really negative 4 times 1. So that, negative 1, excuse me, so that becomes a plus 4. And now when I FOIL all that together, I get x times x squared, which is x to the third, and then I have 4x and a plus 5x squared. I like to write it in standard form, so I always write the x squared before the x. And then 4 times 5 is plus 20. So there you go, and that completes the lesson on 6.7. It's not that bad once you have a handle on synthetic division, and I hope you're starting to appreciate synthetic division, especially since you know how nasty long division can be.